Hey everybody, it's your favorite podcaster, Ben Sherman. Today I'm joined with two of my good friends of mine, Caleb Perez
Hello.
and Charlie Woodward.
Howdy.
Today we're going to be discussing the topic of nuclear weapons and seeing how they have affected nations and the population and our world to come. So I felt like it was a good way to start this discussion would be to talk about this quote that I found by Thomas C. West that says, "Any nation that creates, maintains, or dares to use chemical weapons must be considered a threat not only to its own population, but other populations around the world as well." I think this is, highly relevant in terms of what it means to use nuclear weapons, and that's why we have, treaties to help contain use of nuclear devices and other topics of the like. So, you guys have anything to say about that?
I definitely agree with your points. They're very valid. Also, the quote from that guy, I think, sheds a lot of light on the situation at hand.
What about you, Caleb?
Yeah, I do agree with you. I just don't think that nuclear weapons should be used in warfare or any other situation. Just because of just the destruction and the aftermath, the fallout that occurs, the radiation poisoning. So I do agree with your point.
Yeah, I definitely see where you're coming from there. Kind of on a different note, but surrounding the same topic, there's a bunch of recent allegations surrounding the use of chemical nuclear weapons, and it raises an impending question. Is this completely
In its
immoral? In its simplest sense, one can argue the fact that killing of innocents is exactly as bad as it sounds, where on the back end of this discussion, one can conclude that it's just another form of warfare and that's pretty much where it should end. So,
I definitely agree. I don't think these weapons of mass destruction have enough precision to be able to control where they're hitting their targets and can do so much critical damage and have so many casualties that have nothing to do with the warfare that's going on.
Yeah. All right, those are good points, but let's go on some history of the nuclear weapons. So, the first nuclear weapon was nicknamed Gadget, and it was detonated in 1945, and the chief scientist Robert Oppenheimer and his colleagues detonated the bomb Gadget at, I think it was in New Mexico at the Trinity test site, and the bomb exploded with incredible force, and it shot a mushroom cloud 40,000 feet into the air, and in a flash that was visible for up to 200 miles. And so, what do you guys think of that? Just the first detonation of the first bomb. What do you think was going through those scientists' minds when they first pushed that button?
I think, in a sense, they were probably pretty excited about it. It gave them. They were finally having access to the power that never before had anyone seen anything quite like it, and they realized that they probably took into account the same questions that we're asking right now, but at the time it couldn't have seemed like anything more than a really crazy science experiment. So
Yeah, so when the bomb did detonate, the scientists found out that it did radiate radiation on multiple different scales. Some of these included alpha, beta, and gamma rays that came from the detonation of this bomb. There is really no chemical equation to describe how a atomic bomb or any other nuclear weapon would explode, because it is essentially just the fission of different atoms. So, in an equatorial sense, a detonation of a bomb could be described as this: one neutron colliding with uranium-238 with an atomic number of 92, I believe, would translate it into uranium-239, and it is now considered fissionable, so it can split now. And then when the uranium-239 does split, it splits into 239 NP plus 1 negative electron. And then it splits into another section into 239 Pu, plutonium, into another negative electron. And this continues as the bomb explodes, and each atom that fissions makes an enormous amount of energy. So you can see how this reaction would make just the massive destruction that we'd see overseas in Nagasaki and Hiroshima. What do you guys think of just the death and destruction that this equation caused just in people across seas?
I mean, not only is it just absolutely destructive, but the aftermath you're gonna have to evacuate a certain place or a certain bomb site for more than 1,000 years due to radiation poisoning in that area. And that's a big problem because a lot of places on Earth are already destroyed, and we're trying to preserve as much as we can already.
Yeah, that's definitely a good point. It comes to the stance where it almost feels like a video game. It's like uninhabitable, and it's basically an apocalypse after detonation, and it's uninhabitable. So.
And just a correction on the equation, the Pu stands for a polyurethane. So it splits into Pu, let me go back, Pu 239 plus the NP. So, we'll just go on to how when the bomb does detonate, the most destruction occurs usually after the detonation, so we'll go on to that. Yeah, like I was saying, just the damage usually occurs after the bomb has detonated, like we saw in Hiroshima and Nagasaki. What happens when an atomic bomb explodes? It sends out thousands of tons of radioactive material into the atmosphere, and it falls down, giving it the name fallout. And this fallout can contaminate multiple types of organic organisms, leading to a sickness called radiation poisoning. Radiation poisoning symptoms can range from total loss of hair to poor wound healing to fever to nausea and vomiting. Yeah, fever, nausea, and vomiting are common symptoms, and basically if it's left untreated with a high dose, you'll just melt from the inside out. You'll start to vomit blood, and it's just a disgusting disease. Let's see, some pros and cons of using this technology. Let's see. Some pros, in major wars quickly, like we saw in World War II. He just pulled the string, and that was it. So, I mean, it really prevented a large manslaughter in a land invasion.
Yeah, in World War II, over 124,000 metric tons of nuclear detonation occurred.
Yeah. Okay, so
Insane.
yeah, and like you can use it like we see with MAD, or is it called MAD? Mutual assisted destruction.
Sure.
Each country has a balance on the other, so like it helps with national security. I don't know, that's about all the pros I got.
So in a modern day scenario that we're all facing right now with North Korea, we bring up the same question: is it moral, if we were to be attacked nuclearly by Korea, would we want to return with the same kind of energy? I mean, would it be right to send a return nuke back and possibly take the lives of hundreds of thousands, millions of
possibly
innocents?
millions with our advanced nuclear weapons today, like we saw in Castle Bravo. The hydrogen bomb was like 2-3 times more explosive than the most powerful atomic bomb that we've seen yet. So if we were to drop any kind of I think it's called thermonuclear bomb on any kind of state, it would just be disastrous. Okay, let's see. How we could affect our community. Well, as we saw in the nuclear fallout, fallout can contaminate organic organisms that can be exported to your community, like fish or plants or animals. So you could be affected by the same radiation poisoning that's affecting people tens of thousands of miles away.
Completely contaminating your water, your soil,
Yeah, in the
plants,
area.
animals.
Yeah,
Yeah,
in the area.
in a general vicinity. So, all right, guys, I think we're kind of gonna wrap it up here.
So yeah,
Any
just
last
on,
remarks?
just on a side note, the Pu is actually plutonium. So the uranium does split into NP and plutonium. and the uranium is 238 with what is that? What's the bottom number again?
I think atomic number.
Yeah, the atomic number is 92, and then it splits into NP239 with an atomic number of 93 and Pu239 with an atomic number of 94.
So
Plus electrons, negative electrons.
sounds like our thesis is pretty solid. We don't stand for nuclear devices, and when it comes to terms of destructiveness and overall sake of our planet and our lives, we feel like it's not worth it, right, guys?
Yep.
So I think that pretty much wraps it up. Thanks for tuning in. We're gonna head out. Hopefully we see you next time on a more lively topic.
That was pretty lively.
It was pretty lively. It was interesting,
All right. Well,
There's a lot going on. Thanks for being here, guys.
See you next time.
alrighty.
And that's it. Bye.